Alright, so if you are watching this, you're going to have an advantage because I don't know how many of y'all watch these videos. I know they're pretty bad, but this is actually going to be like a problem on the test, so a little bonus for you if you're watching. Alright, so I'm going to do the same thing here, which is what I need you to be thinking about. I need you to think in your mind somewhere. You should be thinking there's a height of 5 in this graph, so probably what's going to happen is it's going to go out, my radius is going to be 5. I'm thinking, what increments am I going to use? My increments are going to be based on, this is the process I would go through. I would think that this thing is going to repeat itself within 360 degrees. It's going to repeat itself 3 times. Or I would take 360 divided by 3, and so the length of a period would be 120. Alright, so if I had 120 degrees and I was trying to get 5 points out of that, I would take 120 and divide it by 4. So you're looking at 30 degree increments, or pi over 6, however your radians or degrees. So I'm going to go from 0 and then use increments of 30 degrees, and I'm going to go all the way to 360. Now remember, here's my theta, here's my r. Alright, remember that this is one period. So if I were just looking at this to graph, I would say, well, the sine of 0 is 0 times 5 is 0. The sine of 30 times 3, sine of 90 is 1 times 5 is 5. Alright, and we've already established this, so I'm not going to keep doing that. But I would do this 3 more times, right? And it's going to repeat itself. So 5, 0, negative 5, 0, 5, 0, negative 5, and back to 0. Alright, so let's look and see what this graph's doing. So I am going to draw my polar graph. Alright, so let's mark off 30, 60, right, then we've got 120, 150, and we're going to keep going. 210, 240, 270, 300, 330, and then we're back to 360. Alright, so we're going, let's look at 30 degrees. We're going out to 5. So this distance is going all the way out to 5 and then back to 0. So out to 5, back to 0. Alright, so make sure you understand that this distance is 5. Alright, at 90, I'm at negative 5. 90 degrees, I'm going the opposite direction. So this is going down to 5 then. Okay, back to 0. At 150, I'm at 5. And then back to 0. Alright, at 210, I'm at negative 5. So 210, opposite direction. Now I'm just repeating itself. And I could keep going, and I would be back to where I was. Alright, so that's what this graph looks like. Now, I want to go ahead and try to get y'all establishing a pattern, because if I were looking at this, if I was beginning with this, this is certainly what I would do. Make sure you divide your increments up correctly. And like I said, you can either set that equal to 90 degrees, or think about how I taught you to graph originally and think, alright, my period is 120 and I'm going to split that up into 4. That's going to be the increments, alright? Just make sure you go all the way to 360. Now, let's look and see what happens here. The last two graphs, I've got a graph which is called a petal graph. Notice that when my argument inside, the number in front of my theta, is odd, that's the number of petals I get. So I've got 3 petals here. Alright, when we graph that cosine graph, how many petals did we get? We got 1, 2, 3, 4, 5, 6, 7, 8. We got 8 petals. Alright, so our graphs have got this sine of a number theta and then a cosine of a number theta, which has given me a graph that looks like a graph of petals. Alright, so this is the kind of thing that you're just going to have to, if you choose to, start making a pattern so you don't have to take all the steps and write all that out. You can just look at this and say, alright, I know this has got an even number in front of that theta, so I'm going to have twice as many petals. If it's a cosine graph, it's always going to start, your first petal is going to be on that x-axis. If it's a cosine graph, it's not going to be on that x-axis. It's actually going to be where my first increment is. That's the kind of thing that you just have to practice and come up with the patterns to do on your own. But I wanted to just show you where you could actually come up with them and graph them, not knowing the pattern or what the graph looks like.